Hi, it's Miss Fig here, and we're doing factoring review day 1. I know that factoring is the F word of math. Everybody hates it, but I love to factor. So I know that you've done this in Algebra 1 briefly at the end there, but we are going to go back over factoring so now we can get into solving quadratics. So we're going to start by looking at what prime factors of a number are. And so a prime number is a number that can only be divided by 1 and itself. So that means there are no numbers that can go into that number. So 2 is a prime number, 3 is a prime number, 17, 23. So if you're trying to think, is something a prime number, think, can I divide by anything? So like 4 isn't a prime number because I can divide 4 by 2. So 5 is a prime number because I can't divide 5 by 2 or 3 or 4. So prime numbers can only be divided by 1 and themselves, and then so a composite number is a number that has at least one divisor other than 1 and itself. So like I said, 4 can be divided by 2, 24 can be divided by 6 and 4, and so on. So any number that can be divided by another number is a composite number. So when we're finding the prime factors of a number, as you know, there are ways to do it in the calculator, but we're going to do the factor tree method, which means we're going to split up. I don't know what's wrong with my pen lately. We're going to split up the factors until they're all prime. So we're going to make our little factor tree. We're using the number 1296, and you can divide it by any number that it is divisible by. So let's see, 1296, we're going to divide it by 12. 1296 divided by 12 is 12 times 108. 12 is not a prime number. 12 can be divided by 3 and 4. 3 is a prime number. I can't divide that any further. 4 I can to 2 and 2. So 2 and 2 are prime numbers. Now 108, let's see what we can divide that by. 12 again times 9. 12 we said was 3 times 4. 3 is a prime number. 4 is not. So we already did the prime factorization of 12. And so now let's do 9. We have 3 and 3. And I'm circling those because we already know that 3 is a prime number. And so now I've gotten to the part of the tree where nothing can be split up anymore. So the prime factorization of 1296 is 3 times 3 times 3 times 3 times 2 times 2 times 2 times 2. Another way to write that is 3 to the 4th power times 2 to the 4th power. So if you use prime factorization on the calculator, it's going to give you that second way with the powers on it. But once we start factoring and splitting up rationals later, you're going to want to split it up this way. For our answer, we'll write it this way. Then on our second example, we've got 476. Let's see what numbers 476 are divided by. Let's do 2. So it's going to be 2 times 238. I know that 2 is a prime number, so I'm done on this left side. But obviously 238 is not a prime number. So let's divide that by 2. 2 is a prime number. 119. I'm going to assume that it's not a prime number. So 119 divided by 7 is 17. 7 is a prime number because I can't divide 7 any further. And 17, 17 divided by 2, no. 17 divided by 3, no. By 4, no. So 17 is a prime number. It's a large prime number like 23, but it cannot be divided by anything except itself and 1. So the prime factorization for 476 is 2 times 2 times 7 times 17, which is 2 to the second power, which means there's 2 2's, times 7 times 17. So then you guys will do the factor tree method on 1 through 6. And here are some application problems using prime numbers, and we're going to do 10 and 11 together. So number 10 says, I am a number whose prime factors are all the prime numbers between 6 and 15. No factor is repeated. What number am I? So prime numbers between 6 and 15. So let's go 6 is my lower limit. And we have 7, 8, 9, 10, 11, 12, 13, 14, and 15. So now let's pick out the prime numbers. 7, 8 can be divided by 2, so no. 9 can be divided by 3, so no. 10 can be divided by 2, so no. 11, 12 can be divided by 2, 4, 6. 13 can't be divided by anything. 14 can be divided by 7, by 2. 15 can be divided by 3 and 5. 6 can be divided by 3 and 2. So I have 7 times 11 times 13, because it says none of those factors are repeated. So 7 times 11 times 13 is 1001. Now number 11 says, solve this riddle. I am a prime factor of 39 and 65. What number am I? So let's do the factor tree on both of those. 39 is 3 times 13. 3 times 1. 3 divided by 1. So that's a prime number. 13 is also a prime number. 65. We can go 5 times 13. 5 is prime, 13 is prime. So the only one that is the same between them is 13. So 13 is our final answer. So for y'all to do, you have 1 through 6 with the factor tree, and then 7 through 9 with the applications. They're just some riddles for you to solve. And then you will be done for today. Make sure that you upload to Canvas.